Hello everyone, Mr. Waz here, and welcome to WasleyScience. This episode is called The Science of Science. This is going to be a two-parter. With this episode, we're going to talk about basic science inquiry and how to solve a problem sort of informally without writing a lab report. And then we're going to start discussing how to write a formal lab report. We're going to start with how to write a problem, and with that, identifying the independent and dependent variable. And we're also going to discuss how to write your hypothesis and your procedure. So let's get started. Before we even begin, let's just talk about why science is so awesome. Science is awesome because we as human beings are not awesome. We're pretty horrible. Our ability to perceive things is very limited and flawed. Our mind is just filled with biases that distort our reality, even when the information can be right there in front of us. We have a lot of weaknesses. It's just the way it is. But science helps us overcome our limitations. And to do that, we use the scientific method. We create a hypothesis, and we use data to support or not support the hypothesis. And we make inferences on the data collected, and then we can make conclusions. That's what scientists do. That's why science is so important for the success of life for us and for advancement in technology and everything else we do. All right, so let's talk about basic scientific inquiry. The way that an engineer would think is with 3 steps: predict, observe, and explain. So this is a way that you could solve any sort of problem around your house. At first, you start to predict, so you're not really making a guess, you're making an actual prediction that is based upon some sort of past experience. So you begin to notice certain things. You begin to make a forecast, which is like a prediction of what will happen in the future. And then you start to wonder. So that's the whole prediction part. And then you start to make observations. And with observations, you sort of have similarities and differences. So you see that when this happens, then the effect is this, and then when you change it to that. So I know I'm really being general right now, and I do have an example coming, so bear with me here. You'll start to collect evidence when you do this. You start to classify things and categorize things, and then you start to even measure things and see how high or how low it goes. And then after you've done the observation part, you begin to explain what happens and you evaluate. And you also make an inference. And you may even make a graph and model. Now, you probably won't really do this when you're at home and you're trying to figure out something simple like how to get the internet connected. And last, you start to find the pattern. So this is the basic scientific inquiry fashion, and we will use this on some labs when we're not writing a whole lab report. So make sure that you have this understanding of this 3-step process. I hope you're ready for your example. So let's say you have a dog, and your dog's a little bit overweight. And you start to wonder why. You start to notice that your dog is really fat. So you have a family discussion, and this is when the prediction stage that we were talking about before goes into play. So you start to talk about, hey, our dog's fat. Well, let's start to think about what we do. Well, what do we feed our dog? Is bacon good for the dog? I don't know. Should we consider maybe a better dog food, like a brand of dog food? Like maybe one that's holistic too and not just a bunch of byproduct animals? So at that point, you start to make predictions and you start to see which way you want to go with this experiment. So maybe this family at this point is saying, hey, let's buy dog food and try this brand, and we'll try this amount and see if the dog's mass goes down. So then at that point, you start to do your observation part, and you see the dog's mass, and then you see if it goes down while the dog eats his food. And maybe somebody else in the family decides to, completely get rid of the bacon, and then maybe somebody else in the family decides, hey, maybe we should run our dog as well and see if it can lose some weight in that sort of sense. And after time, you probably will start to see your dog's weight go down, and you are still making observations. And so by the end of it, when your dog is at some sort of weight that's acceptable to you, you start to explain things. You say, well, the bacon was too much for the dog, and now we have dog food that's good, and the dog's mass is decreased to an acceptable amount, and running probably helped as well, and getting rid of the bacon also helped. So what you see going on here is things that you do in your everyday life, but what you need to realize is that you are using the scientific method. So the predict, observe, explain, that's sort of a basic informal way of scientific investigation, but 4 times this year we're going to be following the more formal scientific method, which involves these 5 steps: the problem, the hypothesis, the procedure, the results, which have the data table and graph, and then the conclusion. So just so you know, with part 2, that's when we're going to discuss the results and the conclusion, but with this part 1, we're going to do the problem, hypothesis, and procedure. All right, now before we get into how to write your problem, we really need to discuss something important here. You need to be able to identify the independent variable and the dependent variable. I'm going to show you some strategies right after this, but I just want to let you know how serious this is. You have to be able to look at some variables and then easily identify the IV and the DV in order to start a lab, and it's really a technique that's necessary. Honestly, guys, 85% of you, I know you already know how to do it, but that 15% that doesn't know how to do it, your science career is going to just be not fun and enjoyable. And that 15%, you can learn how to do it. You just need to sit down either with me or go over this part a couple times, and you can do it. Anyone can do it. It's just a technique you need to master, and if you just sit there and guess or try to skip over it, you're not going to have a good time. So I just wanted to really make that clear. And if you are having trouble, please come see me and I'll help you out. Alright, so the independent variable is the part of the experiment that you change. I think of it as the cause. It's the part that you manipulate. Actually, back in the day, they used to call it the manipulative variable. But thank goodness they don't call it that anymore, because that's weird. It's the independent variable. Examples are the type of filter paper that you use, the type of exercise, the height of some car ramp, colors of a solar panel. You should notice something here. These are all like things that are types and categories, because those are things that you can change and then see what happens to the thing that you're measuring when you change that specific thing. They're things that you can control. So that is the independent variable. The dependent variable is what is expected to change once you've changed the independent variable. So it's the second part. It's the effect. It's the thing you measure. It's the thing that's numbers. It's the thing that goes into the data table. It's the thing that has the units of measurement. So examples are time, seconds, hours, days, temperature, Celsius, Fahrenheit, Kelvin, distance, meters, miles, centimeters, heart rate, beats per second. Or beats, yeah, it would be beats per second. That one only has 1 unit. But regardless, yes, that is the dependent variable. Alright, so now let's finally get started with writing our lab report. Now the first part of your lab report will probably be the background, which I'm not going to be talking about in the Science of Science. Just refer to your rubric for how to write your background. It's very simple and straightforward. You should be fine with that, and if you're really having trouble, make sure you come see me. We're going to start here with the problem. And the problem is probably the easiest part of your lab report, especially easy if you know how to identify your independent and dependent variable. And all you really have to do is write down the sentence that I have in green here and then plug in your IV and DV. How does the IV affect the DV? You just write that exact sentence. Make sure you have your question mark, and that will give you some easy points for the lab. So that's really all there is to it with problem. Now let's look at an example here. I'm going to go back to my dog that's having a little trouble with the weight. So the dog is overweight. That's not a good way to write your problem. That's maybe a way when you're doing an informal science inquiry, but that's not what we want here. So what kinds of things can we do to lower its weight? That's the first thing we want to think about, because we want to start to establish some independent variables. Well, we could change its food. We could then change its food, and we could call the independent variable type of food. Notice I got the word type there, type of food. So that could be an independent variable. We could also exercise the dog, but you wouldn't want to just say exercise. You'd want to say amount of exercise. So then you can sort of control the independent variable. All right. How do we know that it's working? Meaning, how do we know that the dog is losing weight? Well, that's pretty easy, guys, right? You just measure the mass of the dog each day. So now, how will we know which IV is helping? Okay, so now we got a situation here. So we have two different IVs. We have type of food and amount of exercise. Now, in order to make this a controlled experiment, which is something we talked about when we talked about the most important words in science, we know that we should only use one independent variable. So let's just say with the rest of Science of Science, we're going to go with type of food. So type of food is going to be our independent variable. And then our dependent variable, well, we're measuring its mass, so that it's going to be the dog's mass. At this point, we're finally ready for our problem. Now remember, it's how does the IV affect the DV? So it would come out to be, how does the type of food affect the dog's mass? There's your problem. All done. All right, now we're moving on to the hypothesis of our lab. This is your prediction, but with proper scientific format. It's the possible answer to the scientific question. It's usually done in the following format. If the IV, so you plug in the IV, increases or decreases, so you use the word increase or decreases, then the DV, so you plug in your DV, either increases or decreases. And you don't have to say increase or decrease. You can say change. So if you change the IV to this, then the DV will increase or decrease, because then at the end of your hypothesis, you insert something about the science content itself. Now, I do realize that you guys have experience with writing a hypothesis, and I also realize that some people don't have you write a because section. You just have an if and a then, but you don't have a because. I'm requiring you to do a because section. It'll be, I think, one lab in the year you can't really do a because section, so for that, I'll let you know and we won't do one, but otherwise, you should always have a because section. You should have some sort of reason why you are making this sort of prediction. Our example, with going back to the dog, if the type of dog food, there's the IV right there, is changed, and notice I used the word change and not increase or decrease because I'm talking about a type of something. You can't increase or decrease a type, right? Is changed to the brand from, so that's a holistic organic brand in case you're unfamiliar, then the dog's mass will decrease because from has healthier ingredients for the dog. So there is our hypothesis, guys. Not too bad, right? Now, like I was talking about before, sometimes you can't make a hypothesis because you don't have any background on the relationship between the IV or the DV itself. In that case, you can just sort of guess, and you don't need to have the because part. All right, those two parts were relatively easy. Now on to a procedure. I imagine you're going to be looking at this a couple times. This is the most important part of your procedure, is to write it so it is repeatable. Remember that word from the most important words of science. Some random person should be able to just read your procedure and do the experiment and their trials, and they would get numbers that are very close to your numbers, and that would make your procedure repeatable. So how do we do that? Here are some general strategies for how to write a procedure that is repeatable. Try to have it be between 6 and 8 steps. Sometimes kids have 2 steps. That ain't gonna fly. Sometimes you have 20 steps and it's just too much. Never start with gather the materials. That drives me nuts. You should never say gather materials. It's completely unprofessional. In no protocol or procedure that you ever see do scientists write gather the materials. I don't know why teachers tell you to do that. Don't do it in my class, and don't ever do it ever again. And if a teacher tells you that, tell them, have you ever seen a recipe that says step 1, go to the fridge? I think not. Be very formal and specific. Don't use the word put. Don't use the word get. Those aren't necessary words. Use good verbs that describe the action that you want the person following the procedure to do. Include a safety step. That's really important. You can have this safety step be before all the other steps. Don't just say record data. That one always annoys me. Specify what the DV actually is and how it is measured and with what units of measurement in your procedure. Alright, so let's dive into this even further. Here's some other steps for how to make your procedure repeatable. Make sure you have as many constant variables specified in your procedure. Use the same size, same color, many of those as you can. At least 3. There should be even more. Consistency. Talk about what sort of method that you are measuring the DV. How are you measuring it? You don't have to say what person is measuring it, but what is that person doing? What technique are they using? With every single material that you have on your materials list, that material should be mentioned in your procedure at some point. And a strategy that I have kids do is I have you underline the material in the procedure so that you can count and make sure that every single material has been accounted for at some point in your procedure. Because why would you put a material on the materials list and then never talk about it on the procedure? That doesn't make any sense. Include the number of trials that you do. You can't leave that out, guys. And usually kids are going to have trouble with the first step because now I'm telling them they can't say gather the materials. So your first step should just be explaining how to set up your experiment. How far to set this and set that. What materials to put in where. You could draw a picture of the experiment and have step 1 be set materials as shown in figure 1, and you could show the certain distances on the picture and also explain it in the step itself. All these things that I just explained should really help you write a repeatable and well-written procedure. Alright, we got to do our example here, and we're just going to keep it along with the theme of the overweight doggy. Caution, do not place hand inside dog bowl while dog eats. That was my safety step. That was the best I could come up with, guys. But notice that it's on the top. It's before even step 1. That's what I was trying to show you there. Step 1. Find the mass of the dog using a digital scale each morning. Record mass of dog, pounds. Notice that says pounds, so I included the unit of measurement, along with the date. So see how it doesn't say just record data? It says specifically what things to record. Step 2. Using a measuring cup, measure 1/2 cup of from dog food. Feed the dog food to dog. Make sure the dog eats all the food. Complete this step at 8 a.m. and 5 p.m. each day. So there's specific times there. That's one constant. There's the amount of dog food. There's another constant. And then consistency things are making sure that the dog eats all the food. Step 3. Repeat steps 1 through 2 for 3 weeks. And that's it. I know that one of the things I said was make sure it's 6 to 8 steps, but with this lab, you can't really have more than that. That really does the job. And there will be one lab or two that you will also not really have many steps. Alright guys, we did it. We got through part 1. So what I have for you here is you can go ahead and click on the video on the right and you could watch a song by They Might Be Giants called Put It to the Test. And what I'd like you to do with that is try to identify the IV, DV, and CV. CV being constant variables in each little experiment that they do. The other thing I'd like you to do is, of course, subscribe, which if you just click on the top over here, you can subscribe to my channel. And if you want to just go ahead and jump right to part 2, you can go ahead and click on the bottom left over here, and you can jump to part 2 of the Science of Science. Alright guys, thanks a lot, and take care.